This is chapter 26, problem number 9. The problem reads, the drawing shows 4 different situations in which a light ray is traveling from one medium to another. In some of the cases, the refraction is not shown correctly. For case A, B, and C, the angle of incidence is 55 degrees. For case D, the angle of incidence is 0 degrees. Determine the angle of refraction in each case. If the drawing shows the refraction incorrectly, please explain why. And if the drawing shows the refraction incorrectly, explain why it is incorrect. Alright. Well, first things first, the equation we'll be using in this problem is Snell's law, which is n1 sine theta 1 equals n2 sine theta 2. And more specifically for our purposes, we're going to be solving for theta 2, so we could say that theta 2 would be the inverse sine of n1 sine theta over n2, which we can attain by simply dividing in Snell's law n2 on both sides and then taking the inverse of the sine to isolate the theta 2 by itself. But in terms of us solving for the angles in each case, essentially we're just going to take this equation and apply it to each of the 4 pictures. In figure A, n1 is 1.4 and n2 is 1.6, and the problem states that the angle of incidence, or theta 1, is 55 degrees in this case. So applying this equation, we attain a value of 45.7 degrees for theta 2. In figure B, n1 is 1.5, n2 is 1.6, theta 1 is still 55 degrees, so we attain a value of 50.17 degrees. In part C, n1 is 1.6, n2 is 1.4, and our theta 1 is still 55 degrees. So applying this equation, we attain a value of 69.4 degrees for theta 2. And in part D, it is actually the only one where our angle of incidence is actually not 55. Our angle of incidence is instead 0 degrees. So what we do is you take the sine of 0 multiplied by 1.6, but we know the sine of 0 is 0, so we have 0 divided by 1.4, so we ultimately get a value of theta that is 0.